The electric force is very powerful. A small imbalance in charge results in a very powerful attraction. An ionic bond forms when a group 1 atom loses an electron and becomes a positive ion. At the same time, a group 17 atom gains an electron and becomes a negative ion. And the two ions are strongly attracted and snap together, releasing a lot of energy. The released energy equals the energy of the ionic bond. This shows the progression of ions being created and an ionic bond being formed. Note the size change and the use of plus or minus superscripts to indicate a positive or negative ion. A fluorine atom takes an electron from a lithium atom, creating Li plus and F minus. Note the size changes. Li plus and F minus have opposite charges indicated by the superscript of plus or minus. They attract and become stuck together by a powerful electric force. This is the balanced chemical reaction for the formation of an ionic bond between sodium and chlorine. Note that since chlorine gas is diatomic, we need two sodium atoms, and we end up forming two NaCl particles. This is a video of the explosive formation of ionic bonds, and this is the result of that reaction, the generation of sodium chloride, also known as table salt. Ionic bonds do not form molecules. That is only done by covalent bonds. Ionic bonds create a material with a specific ratio of ions, but not a fixed number of ions. For instance, sodium chloride consists of one sodium ion for each chlorine ion, but that could be 1 each or 10,000 each. Only the ratio matters, not the numbers. With molecules, the numbers are fixed. For instance, water, which is formed by covalent bonds, has 2 hydrogen atoms and 1 oxygen atom. A single water molecule cannot be 4 hydrogen and 2 oxygen atoms. On the left is an image of a sodium chloride or salt crystal. On the right is a representation of the crystal with chlorine ions shown as green and sodium ions as purple. This is an extended structure in that it can include any number of ions as long as there is one Na for each Cl, one sodium for each chlorine. Contrast the representation of a water molecule with that of a salt crystal, not to relative scale. The water molecule has exactly 2 hydrogen atoms and 1 oxygen atom. An ionic solid has a ratio of ions, in this case 1 sodium for each chlorine, but there can be any number of them forming large extended structures, as long as the ratio is always 1 to 1. Sodium chloride isn't a molecule, it's a formula unit, which means it is the ratio of the atoms in lowest terms, just like we can call atoms and ions particles. The reason that we have used and will continue to use the term particles in this course is that it describes a range of entities, including atoms, ions, molecules, and formula units. So we can know that all those are included when we refer to particles, even as the types of particle may vary from case to case.